All right, our section today is proportional relationships. It's the first section that we will do in Unit 4. Our objectives are to identify linear relationships as a constant rate of change. Our second objective is to determine if two quantities are proportional. A ratio, by definition, is a comparison of two values, and we can write a ratio three different ways. We can say A is to B. We can actually write the words out, and that's what this says, A is to B, or we can use the fraction. We like that fraction A over B. We're going to compare that a lot and use that a lot. The second term we have is a ratio. A rate. A rate is a ratio that compares two quantities with different kinds of units. A very popular rate is miles per hour. And this compares the number of miles you can travel over an hour or over time. Rate of change is how two quantities change in relation to each other, and we're going to use this a lot. We're actually going to give it a different term in a few weeks, but we'll still use rate of change a lot. Linear means a line. We can have a line with a positive slope. We can have one with a negative slope. We can have one with a zero slope. We can have one undefined. This last one, though, however, is not a line because it is not straight. We call that a curve. A linear relationship is when the rate of change is constant. And we're going to be comparing the rate of change, which is how two quantities change in relation to each other. So you're going to be looking at how those quantities change to determine if it's linear. If it is constant, if that rate of change is constant, then we know it's linear. So with our first example, that's what we're going to do. We're going to determine if a relationship is linear, and if so, find the constant rate of change. So we're going to start out by looking at A. A has number of transactions. If we look at how these two are changing, you can see the 3 becomes the 6 by adding 3, and the 6 becomes the 9 again by adding 3. Over on the balance side, the 170 becomes a 140 by subtracting 30, and the 140 becomes a 110 by, again, subtracting 30. That's a good sign. If you see that both of those values are changing at the same rate, these are both adding 3 while this side subtracts 30, then we can say it is linear because that rate is constant. It is the same. So to answer the question, is it linear? Yes. And if so, find the rate. The rate is a comparison of values, so we're going to compare this balance of negative 30 to the number of transactions plus 3. We can reduce this rate. We can either write it as negative 10, 3 divides into negative 30, negative 10 times, or leave it as negative 10 over 1. So example B, we're going to be doing the same thing. Here we're comparing the time to the temperature. So as we look at how the time changes, it starts out at 5 minutes, and we add 5 to get the 10, and we add 5 here again to get the 15. To get from 95 to 90 on the temperature, you're going to subtract 5, and then we subtract 8 here. Where these values are not changing at the same rate, we say it is not linear. So to answer the question, is it linear? No. How do we know? The rate is not constant. Okay, to continue with example 1, we're going to look at some graphs. We're going to look at those dots and see how they change. I'd like to actually talk about this traveling down in time, 20 minutes. So I'm going to say minus 20 as this goes over from 8 to 16, 8. Then I'm going to look at it again. From here, it's going down 20 and over 8. Because those are changing at the same rate, we're going to say, is it linear? Yes. If you're not sure, we could connect those dots and look at what happens. pretty straight. And then we're going to talk about this rate. I'm going to put that first direction we went -20 over the second direction 8, forward 8. And then we're going to look at this. Does it simplify? Sure. Both of those values divide by 4, so the top becomes a -5 and the bottom becomes a 2. Okay, we look at our second graph, our fourth example. And we're going to look at how this is changing here. It's going down how much? It looks like it's going down about 500 and over 2. The second value goes down 1,000 and over 4. So if we're not sure if those values are the same, we can look at them as a fraction. We'll compare the -500 over 2 and see if this is the same as 1,000 divided by 4. If we reduce the first one, -500 divided by 2 gives you -250. The -1,000 divided by 4 also gives you -250. Now, because these are the same, then this is linear. So is it linear? Yes. What is the rate? The rate is -250, and you can put it over 1 if you like that fraction. Again, we could draw that line to see if it's linear. That first line wasn't so good. I'll try that again. Nope. I think that's as good as I'm going to get with this iPad. So that's pretty straight. Okay, proportional. A proportional linear relationship is when two quantities have a constant ratio and a constant rate of change, and we'll talk about those at different times. It also has the rate of change is always the same, which is what that second part says. And then this is important. If we look at a graph, it has to pass through the origin. When we have a coordinate plane where the two axes meet right here, it's called the origin. So if I have a graph like this of a line and it does not pass through the origin, this line is not considered to be proportional. However, if I take another line like this and it does pass through that origin, then we say it's proportional. So we're going to look at some examples. The first one, it says use the table, example 2 says to use each table or graph to determine if there is a proportional relationship and explain your reasoning. So what we're going to do with this table is we're going to take our two values just right in the middle. I don't like to take the first one, I don't like to take the last one. And we're going to compare these, and I'm going to put the Fahrenheit over the Celsius, and I'm going to see what that equals. I'm going to do the same thing with that second pair. I'm going to take the Fahrenheit over the Celsius and see what that equals. 41 divided by 5 is 8.2, and 50 divided by 10 is 5. Now, because these are not the same, then it is not proportional, and we would say no, this is not proportional because the ratios are not equal. So we take the second example. Again, I'm going to pick the two middle values, and I'm going to take the mass divided by the weight. So 18 divided by 40, and then do it again with the second one. The mass divided by the weight, and look and see what happens. When I take 18 divided by 40, we get 0.45. And 27 divided by 60 is 0.45. Yay, look at this. These two are exactly the same. So is this proportional? Yes. The ratios are equal. Okay, our second one, we're going to just look at the graphs, or our second set. We're going to look at those graphs and we're going to compare, see what's happening. This tells me that I'm going up 20 over 8, and this says I go up 20 over 8. So is it linear? Sure, it's linear. We've got a constant rate. Is it proportional? To check to see if it's proportional, we look to see if our graph is actually going to pass through the origin. Right here is what we term the origin, so this would be proportional because the graph passes through the origin. On our second example of a graph, you can see that we are going up 1,000 over 1, up, I'm going to have to write that over here, 1,000 over 1. And we can see it's linear. That does have a constant rate, but if we were to draw that graph, it does not pass through the origin, which is here. So we would say this is not proportional. And the graph doesn't pass through the origin. All right, that should take you through your assignment 4-1 Proportional Relationships worksheet. Good luck, and I'll see you later.